Uh, Alhamdulillah Rabbil Alameen. Today also Allah subhanahu wa ta'ala has given us life to witness today, and we should be grateful to Him. Yesterday we mentioned one dua concerning sincerity, okay, and to avoid sorrow, because if a person does an action because of sorrow and it's not sincere, Allah subhanahu wa ta'ala will not accept it from him. Allah is pure and accept what is pure. So whatever you do for the sake of Allah subhanahu wa ta'ala. Although human being we are not complete, we all make a lot of mistakes. We are weak. But the dua is, yesterday I think I made a mistake. I said, Allahumma inni a'udhu bika an usrika bika say anna bi a'lam wastaghfiruka lima la a'lam. Oh Allah, I seek refuge from you to make partners with you. Okay, I seek refuge from you for what did I don't know, because something you think you are doing right, but maybe there's some ikhtilaf. Okay, back to chemistry. Okay, yesterday we said we are going to learn about isotopes, compounds. Okay, a bit of ions, and then we go to our equations, because that comes in the first chapter of syllabus. Yes. Okay, the first part of the syllabus. Now, we are still doing, we call it structure of an atom, but basically it's not completely what structure of atom we are doing, but it has relevance to that. Okay, structure of atom. Now, the first thing we want to say is an element. Okay, we have done this again, but chemistry like that, you do something before, but now it becomes relevant again, then you do it again, yeah? That's why today, when we do when we talk about covalent bonding and so forth, we will go into the complex covalent, they call it complex or giant covalent compounds. When we do compound, we look at that. You know, we mentioned graphite, diamond, graphene, yeah? We're going to look at covalent and ionic bonding specifically, looking at the characteristics of covalent compounds, okay, and the characteristics of ionic compounds, okay? They look at it further. We are going to look at group 1 metals as well, deeply, before we move into, neutralization, okay, these big topics. We look at all that, okay? What is an element? An element have the same atom, yes? Have the same atom. Okay? An atom of an element have the same atom, okay? They may have the same proton. Same proton, but could have different, who know what I'm going to write? Different? Neutron. No, neutron, that's right. Correct. Why is the... may have different neutron, okay? May have a different neutron. And that is the key here to what we are going to discuss. Different neutron, okay? That means an atom of an element could have same proton but different neutron, okay? And that will lead us to the definition of what is an isotope, okay? So we discuss it on the, okay? I put it properly. That leads us into an isotope, okay? So an isotope is an atom of the same element with the same with the same number of protons, but different number of neutrons. Okay? An isotope is an element which has the same number of protons but different number of neutrons. Okay? A classic example is chlorine. What is chlorine? A gas. You can have chlorine 17, meaning the same number of protons, isn't it? Atomic number, same atomic number, but different mass number, isn't it? So you can have 35, and I think 36 or 37, yes? 37. Chlorine 35 and chlorine 37, I think so, yeah. Chlorine 37. So an isotope is an atom of the same, an element, okay? It's atom of an element, isotope, sorry. An isotope is an element, they have the same atomic number, okay? Same atomic number, but different what? Mass number, isn't it?
Yeah.
Different
mass number.
mass number.
Yeah. It's because the neutron doesn't change the state of the atom.
Because it has an extra more neutron than the next one.
Is it because it has no charge? That's why it's still chlorine.
Is what?
Is it because that neutrons have no charge? Is that why it's still chlorine?
Yeah, because no, it's still chlorine because the proton is still 17 in it.
Yeah.
We say that in the what determine an element is the proton.
And the electrons, yeah.
Okay, and where it will be in the periodic table, it is dependent on the proton. Yes. So since the proton are the same, it's the same element. Once you have another element which is 16, then that will be a completely different element. Do you understand? Yes. Now here, we say this is the mass number. And when we are doing mass calculations, we're going to take this one in it.
Yes.
Okay? Mass calculations will come because chlorine, if it is chlorine 35, 2 atoms of chlorine, 1 atom of chlorine will be 35 grams. And another atom of chlorine will be 35 grams. Do you understand? So together it will be 70 grams. So chlorine, Cl2 is equal to 70 grams. Do you get it? Yes. But you have to know what chlorine is it. Is it chlorine 37 or chlorine 35? Do you understand? We will do the calculation of what to take. Okay? There's a calculation what to do. Okay? So an isotope, basically an isotope means same atomic number, okay, but different mass number. Isn't it? Simple. That's the simplest definition of what an isotope is. An atom with the same atomic number, but different mass number. Do you get it? Yeah. So, now, the next thing we're going to discuss is a compound. Before we go to our target, I'll give it 20 minutes, tell me, because it becomes difficult to download, yeah? Now, a compound. All this I'm doing, I'm trying to get to something, okay? A compound, what is a compound?
2 or more elements.
When 2 or more react, yes? So, when 2 or more elements react, yes, they form a new substance, yes? You can say substance. And we call that a compound, yes? A compound, in it. But what happened? The atoms form a bond in it.
Chemical bond.
The atoms form a chemical bond. Bond, yes? And the bond could be ionic. It could be an ionic bond or covalent bond. Let's demonstrate. An ionic bond, let's see an ionic bond. Okay, yesterday we said chlorine and sodium in it.
Yeah.
Now let's look at calcium oxide. Okay, they call it lime. Okay, calcium oxide will be formed, is going to be calcium plus oxygen will give you calcium oxide, yes? Will give you calcium oxide. Look,
Metal oxide.
it's a metal oxide, yes. Calcium is a metal plus calcium plus oxygen with a calcium. Look at the way I write it. Capital C, small a, and a big capital O. So calcium oxide. Okay? Is it balanced?
No.
We are going to do balancing next time, but I'll show you how to do it. Look, if you are balancing, this means 2 oxygen. So if you want to put 2 oxygen in the next side, don't put like this. No. You put like that. You see? Okay? Because it is not 2 oxygen that is bonding. 1 oxygen is bonding with 1 calcium in it. Yeah. But for the complete equation, you need 2 of that, innit? Because calcium is 2 plus in it. So you need 2 oxygen in it. Now, look at it. Look at it. 2, you make this 2. Now let's look at the electronic structure. Okay. Now we have calcium with 2 here, Ca. Calcium is how much? 14. 14.
40.
No, I mean the atomic number. Calcium is atomic number is how much? I know there's two in the atomous cell. Because in group 2. 20. So we need another 20. So
another 8.
we need another 8. And then the last we need 2, we have 2 out. Okay? When that reacts with oxygen, 2 here, 6 here. Six. You see, since it is an calcium plus O2, CaO, yes? 2. Since this is a metal and a non-metal, then it's an ionic bond in it. Yes. So what happened is, what do you call it again? Oxygen need 2 more electrons. To demonstrate better, we make this a circle. Okay. Calcium has 1, 2, 3, 4, 5. It has 6, yes? No. Oxygen is 2, 6. If I make mistake, tell me.
No, it's 4. 4.
No. So oxygen, is 8. 2 and 6. Yes. 6 in the atomos, isn't it?
4 in the atomos.
Yeah. 4 in the atomos.
Sure.
Are you sure?
Yeah.
No, 6.
It's 4 because
No.
oxygen altogether 6.
No, calcium, this is how it is. Now, so calcium can donate 2 electrons, calcium. And oxygen can receive 2 electrons, isn't it?
Yeah.
Yes. So basically, what happened is calcium will lose 2 electrons and become calcium 2 plus. And oxygen, okay, will gain 2 electrons. It become oxygen 2 minus. Okay? Now, how it happens, you have to draw, let's say we draw the outermost cells. Okay? Okay? This is calcium, this is oxygen. So, No. Sorry. This is not sharing of. You should have told me this is not sharing of electron. You should have told me yes. So it look like this, ionic bonding. Now it will be be careful. Ionic bonding look like that. You know, ionic bonding is not sharing of electrons. So
There's 2 plus.
yes, yeah, 2 plus, yes. So oxygen now will be 0, 0, 0, 0, 0, O2, oxygen, and 2 minus. In the exam, this is how you are exactly supposed to do it. Okay? Yeah. This is ionic bonding. This is how it happens. Okay? So,
X is 1 under 2 because X is from the other.
this is,
The thing, because we got 2 X's in it.
who? Which one?
Oxygen got 2 X's, not 2 zeros.
Oxygen is 8 here, 2 here.
No, I mean you got the 2 X's. You know how you when calcium you put X's. Calcium's the one that lost the X's. So oxygen, you get
It should be like this. It has 2, 2, and 8, 8. 2, 2, 8, 8. Okay? 2 and 8.
this one together.
Now, this is called a compound. Okay? Because the characteristic of this calcium oxide will be different from the characteristic of calcium and oxygen. It will be an entirely new compound. If this is gas, this is metal, this may be a solid. The color, texture, and everything will be different. That's what we call compound. And that's why they always say they are chemically bonded. Yes? Bonded. That's here a compound. Okay? Now we see, so calcium reacting with oxygen. Okay? To form a
metal oxide.
metal oxide, calcium oxide. And this is a
Compound.
ionic compound. Now let's look at hydrogen, okay? Or let's look at hydrogen. Hydrogen plus oxygen will give you H2O, okay? If you're going to balance this is 2 here. But this one, 2 here, how many here? 1 there in it. We're going to do this later in it. Later I'm going to do it more professionally, okay? We put 2 here and 2 here in it. Now let's look at how it happens. Okay, so 4 in it. 2 times 2, 4. 2 times 2, 4. 2 here, 2 times 2, 2 here. So it's complete, yeah? Now how it happens, okay? The mechanics is this. You have hydrogen, okay? That's nucleus, yes?
This would be covalent bond, isn't it?
Yes, covalent bond because it's a gas and a gas, isn't it? Yes. Hydrogen and another hydrogen, okay? That's nucleus, okay? Reacting with oxygen. Okay? 0, 0. 2, 2, 1. Okay? Because it's a gas, each one is a gas, you are going to have a covalent bond in it. So that means this hydrogen will come here and this hydrogen will come there in it. Okay, now let's see. We draw our oxygen, okay? And then 2 here. Okay, so now what happened is
You missed 1 over.
hydrogen, it 1 electron in it. Hydrogen with it 1 electron. So hydrogen, the maximum number in the K cell, remember K cell is 2. Okay, Maximum number in the K cell is 2. 2. Okay. The maximum number in the K cell for hydrogen is 2 in it. The maximum number in the K cell for this hydrogen also is 2. But the maximum number for oxygen is not the K cell, the L cell. Because oxygen has 2 cells in it. 2, which is the maximum, and this one has 6 there. So it needs two hydrogen electron in it. Atoms, yes. They want one atom, one electron, they all share that. For hydrogen, this is the K cell, but for oxygen, this is the L cell. So L cell can take how many electrons? 8 electrons, isn't it? So everything is fulfilled. So this is a covalent bond. Okay? You can also look like this, like this. Hydrogen, one hydrogen here, one hydrogen here, in it. Yes? And this is oxygen. Okay? We'll look at this later. Okay? When you look at ionic bonding in greater detail, you'll see all this. Yeah? Okay. Now, to conclude this phase of first part is this. An element 20? Okay. An element, same atom in it.
Yes.
Same proton in it, but it may have different neutrons in it.
Right.
So if it has different neutrons, that means that element is an isotope. It has 2 different atoms. One have a different mass number to the other one. So they call it an isotope. A compound is where 2 atoms combine together chemically. Okay? They either share electrons or they give away, donate a receive electron. That is a compound. Yes? And an ion is a positive charge or positively or negatively charged atom in it. Yes. So an ion, a cation, and anion in it. An anion is negatively charged. A cation is positively charged. Yes. But there's something called a molecule ion. Yes. A molecule compound ion. We're going to do that in the next 20 minutes. We're going to do that, yeah? You will see. Because if you don't do that, I give you an equation, okay? This is an acid, sodium hydrogen sulfate from sodium hydroxide, okay? Will give you sodium sulfate plus what? H2O. This is called neutralization, okay? Neutralization. When a base react with an acid, you have a salt and water. This is called neutralization in it. Very famous reaction in it. And this you have to know. You have to know that when a base reacts with an acid, you have a salt and water. Yes? Now you'll ask me, what is this OH here? Why? We know sodium is plus, but what about OH? Is it oxygen coming, hydrogen also coming? And then what is this? This should have been minus in it, because one positive, one negative. But how do you get this one negative? Okay, look at sodium. We know sodium is 1 plus. But what about the SO4? SO4 is actually 2 minus. Why? Okay, that's what we are going to do before we do equations, okay? So you understand, okay? Thank you very much. Jazakumullah khairan. Barakallah fika.